Thank you, Agus. Last time I think we forgot to start recording. So yes, the pre-roll is about this, about summer camp, because summer camp is coming in January in Montevideo. So yes, if you haven't heard about summer camp, that's weird because we talk a lot about this. So happy for you if you come here. So what is summer camp? So it's here we are. Summer camp is our event of the year that it's in Montevideo. The idea is come here to Montevideo just 1 week, the last week of January, to collaborate, be together, do some open source projects together, have human connection between us, between the community, between people in video. And yeah, it's the place for all developers, engineers, and curious minds to meet up and do more social stuff. So we have two flavors of the summer camp. We have the summer week, that's the in-person part of the summer camp. It's going to be last week of January. And we have also the summer projects. That summer projects starts in November and will end at January. So the summer projects basically is people, proposing ideas that say, hey, this would be great if we can achieve this project, this idea in 2-3 months. The idea is that idea should be an open source project to be built, and that has impact for the video community. We have done a lot of projects, like last year we helped a lot with a MOQ player on the library and other projects that you can check out on our webpage. If you want to submit an idea, there is the QR code. You can screen cap, or we can share the link on the chat right now. The idea is to share any type of idea that will be relevant for the industry and you think that might be relevant. The idea is to have, if you are submitting an idea, is that because you want to be a tech sponsor. The idea is that the tech sponsor comes to the meetings and help everyone who wants to put their hands into the summer projects to, give some guidance and also help to decide what to do or what different approaches to implement. Again, it should be open source, and the idea is that engage with other people and together get to a final result. The deadline for submitting is October 10th. That's the deadline. Then we're going to do a vote process. We are going to share the links, everything for you to vote. And then in DMAX, we are going to just say who were the projects that most people wants to work with. And in November, we're going to do the kickoff of the projects. So summer week, 5 days in person. If you want to know more about this, and come here and we have different tracks for contribute. Another one in tech. We have a track about woman empowerment. That's super cool. And the cultural track. If you want to know more about this and come to Uruguay, you can talk to Scott, for example, that came last year, or Babesh, and happy to have you in person in Uruguay. So who's going to start?
Sure, I can kick it off. Share screen.
Hey, amazing.
You see that all right?
Yes, I can see you. Thanks.
Beautiful. All right. So hi, everybody. I'm Zachary Cava. I work at the Walt Disney Company in the media platform there, making all the content go everywhere all the time. But today we're talking more specifically about Dash HLS and server-guided ad insertion mechanism interop. So, over the last years, we've talked a lot about enabling server-guided ad insertion, a lot of focus on HLS based on the standardization of the HLS interstitials there. But we've continued to pursue equivalent mechanisms and work within the Dash community as well. And luckily, we've gotten to the point with the 6th edition that we have standardization there. So I wanted to walk through kind of what was there, in case you've been following this at all, and then how that evolved into what finalized in the Dash spec, and then close that out on looking at interoperability between the two specs and like what works and what doesn't work together. Spoilers, it works very, very well together. So we can dive right in into it. So standardizing Dash signaling. Now, if you recall, kind of pre the standardization stuff, there's a number of different mechanisms that were being pitched for usage here. One of the existing mechanisms was Xlink. This had the ability to remove or manipulate periods within the timeline. But it was felt that this was a little bit too encumbered by existing semantics, and there's a lot of edge cases related to live playout. that made this a non-attractive approach for a number of folks. And so what we then had looked at was this concept of a media presentation insertion event. This was mildly inspired by the HLS interstitial aspects. It eliminated the X-links schemes, but it really reduced it into a simple event presentation, but it wasn't really robust enough to capture all of the overall use cases that we were looking for. That evolved into another version of it, which was the media presentation insertion v2. And that introduced more semantics, like when can you insert, when can you replace, but it ended up doing a lot more interesting things and like complexities around the live scenarios to make okay, go replace, but stay listening to this. It was a little too cumbersome to work with. And so where we finally ended up with to enable this is Dash alternative media presentations is a general concept and 3 key components to make it work. The first is the alternate MPD events. The second is a concept called list MPDs. And the last is a thing called a linked period resolution. So we're going to look at each of these 3 things and we'll provide as best examples as I can provide for them. But then we can absolutely talk about them as well. So alternate MPD events. So this is an event stream that'll happen within the MPD itself. It's split into 2 types. So the decision was made to split insertion and replacement mechanics so that they are explicitly signaled independently. The insertion, both of these are operated in an on-receive dispatch type mode because they're placing an action within a point in the timeline. But there are actions you might want to take earlier, like preloading. Each of these types have like a sub-event structure. So insert MPD element, replace MPD element. We'll talk a little bit more about that. These are only allowed in the manifests as part of these schemes. So no e-message boxes for these. And then the real unique thing between insertion and replacement is insertion is only allowed in static, whereas replacement is allowed in both static and dynamic MPDs. So looking at the commonality, those event elements have 4 common attributes among just kind of the general ones. The URL, this is the URL to the alternative media presentation. The earliest resolution time offset. So this is a signal as to how early you could go resolve that URL relative to the point in the timeline that it's going to start. That's your preload. Service description ID. This allows you to connect it to a service description element elsewhere in the MPD and any semantics you have on that. And then the maximum duration. This is the max amount of time that the alternative presentation can play for. If it's not there, it's implied that it's unconstrained. So then we look explicitly at the insert MPD element. There's no additional attributes for that case. It's just those 4 basic ones. And it always mechanically leaves and returns at the same point. So if you have the primary MPD timeline here, represented by this gray bar, your insertion event is going to point at this point in time. Your preload range is signaled by the earliest presentation resolution. I've forgotten the very long name. And then the alternative MPD timeline will be played out from that point and then return to it. So you'll leave at that insertion event point and you'll resume. Very, very simple, very kind of straightforward, on-demand, add play out. When we look at the replacement event, there are 3 additional attributes that come into play. The first is the return offset. And this is the non-negative time from the event presentation time that you want to come back to. Clip, which is whether or not to clip the alternative MPD in case they do late execution. And then start at the playhead, which is the ability to control whether or not you are starting at the start of the alternate MPD or at the live head or a time delta within the alternate MPD. There's a little bit of nuance to it. But it allows you to keep things in sync. So if what you're doing is doing a live replacement, so suppose you're on a live stream, it has a 90-second ad break, and you're inserting 90 seconds, but somebody joins 30 seconds through, you can either start the ad break at the original and then cut off the last 30, or you can start it at the 30 and play the full 6, or cut off the first 30 and play the remaining 60. And you could also say with clip false, just play the whole thing and then offset the people from the live head. There's a lot of options there, right? Very classical. So when we think about from the replacement too, there's also this concept of listening for updates. And the primary MPD is always listening for updates because you're always pulling on it. And there's a new event status called update that allows you to provide additional details. So if you want to do a duration or a clip or a return, you can update the event information. So let's walk through a little bit of an example here. You'll get your first replace MPD event somewhere earlier in the timeline, right? This is like physical time. That will point to a start point at some point in the future, which is probably going to be pretty close if you're in an actual live space. Of course, you'll have that preload offset time that you're signaled the same way as before. You're going to exit at that time point, and you'll start playing your alternative MPD timeline. Let's just assume we're playing at the live head here for a little bit of simplicity's sake. As you're playing through, when you say we reach the second yellow bar here, that we get another update for replace MPD with an event status of update that gives us a return offset and a max duration, right? Like it was an unknown duration or an early cutback, and now we need to go back to the mainstream. Ultimately, the user will come back at that second dotted line, so that first gray portion, or that dark gray portion of the primary timeline, will not be seen by the user. The second gray portion of the alternative MPD won't be seen by the user. Of course, all these semantics can be adjusted. If you said clip false, you could play out the entirety of the alt MPD and return at that same point. You could, so that's the general event semantics, right? And that we've said nothing about the actual alternative MPD structure, just that there is a secondary timeline that the player is playing out and working out. Let's talk about the secondary timeline. So you can do a standard period or standard multi-period dash. But what you can also do is a new thing called the list MPD. So it's an MPD of type list, and it has effectively just a list of periods that may or may not be full. You can have a complete period in there, or you can have what is called a imported MPD or a linked period resolution. And so if you wanted to do something like a lead in and lead out, lead out and lead in bumpers on an ad break, and then have the ad in the center, you could serve to all the users kind of a more static cached base layer, and then do individual resolutions for slots, or you've got a lot of variability that you can do. Yeah, and so then that second mechanic there, the imported MPD, which these two ad X1, ad X2 have contained within them, is a heuristic for taking an MPD at a secondary location and bringing it in through resolution. So you can the spec goes into what does copy over and what doesn't, and how the duration's affected. So you're allowed to like shorten the overall imported duration by declaring a duration on the containing period. But then you can also provide event streams. So if you wanted to make the list MPD the unique resolution for the user, and then the imported MPD is all the static content coming in, you could still have unique client-specific timeline event streams, so that you could have like unique ad beacons and metadata for those resolves. A lot of flexibility, a lot of interesting things. But the kind of the important part is like, how does this interrelate back over to HLS? When you think about the interstitials, just to give us a refresher, right? Interstitials have date ranges that there's only kind of one type, and you're snapping in, snapping out. It's a full replace, or you're resuming in an offset, and then you're pointing at a single URI or a list. Cool. That's very basic semantics and very similar. When you do a list, right, you're getting a list of assets in their blobs of URI and duration for each one. You can put additional metadata in there, allowing your list to be the unique resolution point. And then very recently, if you've been tracking, there's a skip control concept that's come in, allowing you to trigger some skip details. This does exist in the dash one too. I just didn't go into much detail. So from a high-level mechanic alignment, when you take the dash side, you've got opportunity signaling with the alternative MPD event scheme, the customized container as the list MPD, and then the preload controls as an earliest resolution time attribute. On the HLS side, you've got the interstitial date range scheme for the opportunity signaling, kind of very one-to-one here. Right? The only difference being the MPD having the two types, but you can normalize those pretty closely. The customization container being asset list versus list MPT, I believe you could write a resolver that could basically do the same function and then render out XML or JSON and with the same functionality. And preload controls, the interstitial or the HLS spec is looking at a preload date range scheme, but there's still a little bit more iteration that's happening on that one. So just as a couple other notes and details. So the MPD replacement mode can 100% emulate all the insertion mode stuff by setting return offset equals 0. So like that would have the equivalent semantics. There's a question of whether or not you would implement both or just implement replacement. Again, it's kind of a detail. Technically, the dash mechanisms allow you to do nesting beyond one depth and to do live content. So you can do live to VOD to live if you really, really wanted to challenge yourself. That is explicitly prevented in the HLS side, though. So from an Interop perspective, we think about it as just one level. The asset list has no per asset preload control. This is something I didn't actually mention so explicitly, but the list MPD allows you to signal the preloading of the individual periods when it's an imported MPD. HLS date range updates allow only changes to the attribute, but the dash event you can change the whole payload. Whether or not that becomes semantically meaningful, we'll see as implementations come through. But it was great work by all the contributors and editors to get to this point. So we think about continuing related work. Now that we have all this information, it's great. In the DAS HLS group, we are taking the interoperability points and formalizing them in the next version of the spec. We already have all the details documented within the CTA Wave HLS GitHub, so you can already see all the interop points and holdback mechanisms that are required if you're interested there. And then similarly, the SVTA advertising working group will then be able to go and establish the metadata carriage parallels, because we've already established some for asset list, but the next version of the spec can go ahead and include these as well. That's it. We finally have a totality of interop to get us the server guided insertion everywhere.
Amazing. Thank you. Oof. Whoa, we have questions.
Surely.
Go for it.
Yeah, how far away are we from having like the release, right? Like the
6th edition?
Yeah.
It's a great question. I believe the final second final editorial version went back to ISO. ISO had some notes, and then it was correct. Those were corrected, so it should be published kind of imminently.
So you said imminently?
Yes.
Oh, that's exciting. Okay. We don't have any. I assume there are no player implementations yet, unless like the Dash.js players are already doing implementations.
I'm not sure about that. Maybe
So,
Nicholas, you know.
Yeah, we are working in implementation in Dash.js. In particular, I just shared the branch in GitHub from our fork of Dash.js that, in fact, we are finishing some live replacement with live content and replacement with live content, some details in that part in that implementation. We are finishing the testing on what we have done, finding a lot of tiny issues. But yeah, the idea is that we are going to contribute, of course, this stack to the Dash.js main branch. But we are close with Dash.js, and Shaka Player already supports some alternative MPD. I'm not sure what exactly. I know that they have like for server guided insertion, like the alternative MPD with insert, and I think they're replaced with a VOD. Never try with live content. So just to take note is the Shaka Player implementation. They assume it's an add whatever you are doing alternative MPD. But the Dash implementation doesn't. So if you want to do with Dash.js, maybe as is a scenario where you have a content and you want to do a blackout because you have a live content and you are putting another live stream as blackout and then doing server guided insertion with some VOD or whatever, you can achieve that with the implementation we are trying to finish with Dash.js. So please test our repo and find bugs.
You said the Shaka implementation, is that in like the production release, or is it like on a dev branch or something?
Yeah, it's on the main branch. Yes, it's on the latest releases. They already support some alternative MPD plus interstitials if you're using HLS with Shaka.
Oh, perfect.
Fanso.
Yeah, I just wanted to leave a comment on the imminent statements. You're absolutely right. We managed to hand over the spec a couple of weeks back to ISO. It went through the editor's hands, and we are waiting for it to be released into the ballots. But that means it goes around the world, and everybody needs to check it off, and only then it will be released, right? So imminent, I would put that in quotes. But from, let's say, the editor's perspective, we didn't hear back from ISO for more than 5 weeks now. So that's a good sign. They seem to be happy with the document. And we do not have any other things around the text. So the text is finalized. And hopefully this will be a smooth ride. The only thing that I can say for people and companies that are SVTA members, SVTA has a liaison with MPEG, so you have access to that final text that was submitted to ISO through SVTA.
Perfect.
It's good. Good call out. Good call out.
I'll go ask in the SVTA Slack where to find that then.
Yes.
Thank you.
I would guess Florence will have the answer for that. Great. Any other question? Nope. Okay. Thank you, Zach, for your presentation. Amazing.
Yes. Thank you.
Now, thank you. And now let's go with Oliver.
Hey,
This is
yeah, it's
yours.
going to be hard to follow. I should have been first.
Yeah, please introduce yourself and the stage is yours.
Yeah, thanks. Yeah, my name is Oliver. I work for Yospace. We are a company specialized in ad insertion. And my presentation today is about why ad insertion doesn't pay. And actually, if you want to get paid, you have to do ad measurement. And so that's something that is most of the time not really think about. So I'm just going to throw you some ideas on how you can do measurement. And we are very lucky because we have two of the people who are very doing a lot of work in this space. We have Zachary, and who is doing one of the format I will present, and also Nicola, who's been heavily involved with the other one. So very honored to be part of this guy. So first, how do you do measurement? So measurement is done with tracking URL, and we call it also tracking pixel, tracking beacons. There's a lot of names, but basically it's this huge URL that you have to call every time you hit certain points when you're playing or when a user is doing things. The important things here is just that this URL can be huge, that it has some macros inside, as you can see at the bottom, which needs to be replaced by the players, and that 1,000 of this URL is called a CPM, which is like a cost per mile, which means like cost per 1,000. And 1 CPM is basically what you say when you talk about money. So you would say 1 CPM is going to be $20, $50, so this kind of thing. So this is how you get paid really. It's per CPM, so per 1,000 of this ad playback. So when and where do you fire this tracking pixel? There's different categories, and when you fire them, there's what we call the standard measurement, which is just when you're going through the playback, you're basically sending these tracking URLs to say that you're playing through the ads, and you're just providing this information that is going through all of the ads. You're also telling if you have some user interaction, like the mute and mute, and of course if you skip the ads. And then there's some enhanced measurement, which is something that has been done for a lot of time without standards and is not being standardized. And this idea of viewability, which is as much as you will ever know that somebody is watching the ads. So it's like how much of the screen is actually used by the ad? Is there anything covering the ads? And is the sound actually on the device? And so where do you send? You have this ad chain, which is something that I make as easy as it is, but it is really complex. So when you have your publisher, so your broadcasters, whoever own the content, usually will have an ad servers, and these ad servers help them to manage campaign. If you're big broadcasters like Disney, then you also have an ad cell. So that's a team you have inside that calls advertisers and tells them, hey, I have some cool TV show coming up. Do you want to advertise your drink or your car or whatever? And then they make some deals with them, and then they get campaign that they set up in the ad servers. But if you don't have that, or if you want to have tap on more external demand, you have what we call SSP, which is like a supply side platform. So it's a platform that will group all of your broadcasters together, all your publishers, so everybody who is saying, I have some space to get ads onto. And this guy will then contact the demand side platform, which is basically where advertiser will say, hey, I want to buy some space to put my ads on. And this how they will talk to each other. And then through some call, they will basically be able to bid on space that is available. So how it looks like in real life is that you have your ad servers, which then call the SSP, and then the SSP are able to call multiple DSPs, and the DSP will get different ads. The ad publisher is also able to call the SSP directly using OpenRTB, or even call the DSP, and that's what we call advanced bidding, or what is called in the website header bidding. So they are idea that they are telling to this SSP and DSP, I have some space available, and this guy can make the bid, and then they can provide the bid to that ad server that can figure out how should I use this. These bids are actually better than our inside campaign, or should I go through this way? So it allows them to optimize the space and the revenue for when they can. And so all this just to basically tell you that at the end, what this means is that for you, when you're replacing your ads, when you have direct sold ads, you're just sending the tracking to your ad server, because you just need to tell your ad sales guys that, hey, actually ad has been played. But when you're coming from the DSP and the SSP, when it's been going through what we call this programmatic ad sales, then you have to tell every element of the chain that the ad has been seen. And so you will end up with, for example, the third ad, which you have to tell 4 different places where the ad has been seen. And as you've seen at the first, like the tracking URL is pretty big, which means that you're actually getting quite a lot of metadata that you have to send with the ad in order to do tracking. And so how it's done usually, like today's in SGAI and SGAI, just because we are SGAI and SGAI companies, so I'm not going to start with client side. But the idea here is that every SGAI and SGAI module companies will provide you with their SDKs, which will be basically a simple application, small application that you run on your next to your player. We will get information from the player of what's being played, and then this SDK will take care of doing the tracking for you. So it helps you to get the metadata from the SGAI providers and to send the beacons. And the things here is that this is not standardized at all. So everybody has their own source, everybody has their own SDK. So if you switch from one provider to another, then you have to implement your SDK again. And if you use Player, there is no standard implementation about tracking. So all this is customized, and there's a lot of different devices. And you know that when you're on connected TVs, they don't really necessarily be very keen on having you adding some extra codes that they don't control, that maybe is a bit too big for what they want. So all this makes things a bit complicated. Another thing that is difficult, that we don't really think of, is like knowing the playhead position in SGAI is pretty easy, or not as difficult as SGAI, I will say, because you're basically, when you're in VOD, at the bottom is 0 to whatever, and then the playhead just goes through, and then when you're going through the ads, it's just going through. It's nothing really difficult. When you're in Dash and when you're in XLS SGAI, it's basically behave the same as in VOD. So the Apple, in the Apple world at least, I think when you start your session, then the start of the live manifest, or the first segment in the first manifest, is 0 time, and then the playhead position is reported toward this, just like if it was a VOD asset in a way that you're just growing up. But in live SGAI with Dash, depending on the player, then you're getting different point of reference. And so when you want to have something that is homogenized around all your players and your different streaming formats, being Chaka, Dash, SLS, then again, you have some difficulties here because you have some translation to do in order to make it work. And SGAI is a little bit more complex and a little bit easier also in a way, because here, as Zach was saying, you have 2 timelines. So when we look at VOD, usually it's pretty easy because it's an insert. So you have your timeline, you break it at 30 seconds, and you get an interstitial event, and then your playhead starts again from 0 to the end of the ad breaks, and then go back to where you were in the content. So nothing really too special here. But when you're in live, then that's where the things are a bit more complex. And here, like the case I'm showing is something that is done in France and some other markets also, but especially in France, they have this idea to have spot-to-spot replacement. And so instead of replacing the full ad break, what they want to do is replace each ad spot individually. So some users might get the first ad replaced, some might only get the second one, and that's really depending on every users. So that makes things a bit complicated, because now instead of having one interstitial covering the whole ad break, you have each interstitial covering each of your ad spots. And so when you're playing there in a row, then you have different behavior against, depending on each of the player. So on our side, what we have noticed, for example, is that with the Apple player, the content the content playhead when you're playing your interstitial is not updated as regularly as it would be when you're playing the content playhead. So you cannot rely on this playhead to just give you like a growing playhead positions. You have to use the time where you left the interstitial and then use the playhead from the interstitial to compute that position if you want it to be something that is relative to your start of the playback. We also have found like some bugs in the latest iOS version that when you have 3 interstitial next to each other, then suddenly when the HLS the Apple player starts the 3rd interstitial, it will start at the end of the interstitial or even after the interstitial finish. So you have like this strange behavior that didn't happen in newer players. And we also have seen in HLSDS when you have back-to-back interstitial, this time is just getting you an interstitial start at the start of the first interstitial, and then he plays all the interstitial next to each other without any interstitial event, and just when it's finished, then you go back with an interstitial event end. And so what I'm saying here is that again, like you have these difficulties that every player behaves slightly differently. So something that you would think is kind of easy to do is not that easy, and you actually have to think a little bit about it on how to provide this playhead position. And so why I was talking about this is when we look about the ad measurement of the future, there's 2 standards has been working. And again, we have the 2 mastermind a bit behind this. So the first one is this SBTA ad creative signaling, which has been led by Zachary. So if you have any question, he will be able to answer. And if I say something wrong, he will be able to correct me. But the idea here is that this is client-side tracking done through a standard, which means that you're getting the metadata with the stream in a standard way. And that means that when you can implement the tracking in the player that just follow the standard, and then you don't have to do anything specials. And it's done in a very simple and elegant way, I would say. Like it's using a JSON format, which you can have like here inside the manifest, but you can also have, of course, out of band. And here you see this is very simple. It's only 1 impressions, 1 ad, only 1 third party that you're reaching to track each event. And there's not even all the events. We didn't put like click through and everything else. But you see it's already taking a bit of space. And then imagine if you have like this huge long URL and you have multiple of them. So that would become quite a bit of data to put inside the manifest. So from our side, we will recommend to use out of band when you're doing this kind of tracking. But the way it's done is, like I said, and I show you, it's a JSON-based standard. So that's a very nice way to read things. You can have this metadata in and out of band, but again, to keep manifest light, we think that using out of band is much better. And the version 2 of the standard defines all of the major tracking events that you need to do ad break replacement. Version 3 will provide you support for non-linear companion ads. So when you want to do a little bit more things with your player during ad breaks. And then again, you still have to replace this macro yourself. So that's hopefully going to be something that is implemented. And another advantage here on adding this metadata providing to your player, that you provide also awareness about what's happening for the player. So if you want to forbid user to scrub during the interstitial, you might be able to use the HLS and the dash way of no skip, but you can also, here you could have the ability to provide a countdown for the skip. So that's something that a lot of advertisers give you, that you can skip after a few seconds, which as far as I know is not possible with the HLS and dash implementation per ads. And then of course you can see how long is the interstitials and how many ads are there, and you can provide a click-through and this kind of extra enriching operation that you can do during the ad breaks. And then we have the other standard, which is led, I don't know, I'm not sure if that's the right word, but actually Nicolas is heavily involved in it and been doing a lot of work to be able to also support the ad tracking. And then here the idea here is more to do like a client-guided tracking. So compared to self-guided insertions. So this client-guided tracking, the idea is just your player is relying on CMCD, which provides a lot of information about the playback sessions. And we have added some events, in particular the playhead position and the skip events, the mute, unmute, all these user interaction events that you can track with CMCD as you can as you need to, so that you can on your SGAI platform you can receive this event and fire the tracking pixel accordingly. So that allows you basically to give a tracking that is as accurate as a client-side tracking you're doing now with an SDK. But of course, this time is done server-side, so that means ad blockers don't have any effects on it. So that's a major advantage. But of course, here you're missing the awareness on the player. And so yeah, that's basically the main thing is that the CMCD, all the tracking is done by the endpoint. You have it as accurate as it needs to be. At least we think so. And then again, the major advantage is that you have no awareness. And so when we compare the two, I think the main things that you have to think about that these are two standards that allows you to cover all devices. So I don't think there's like one standard that will be take over the other one. Probably the SBTA is going to be the one that is used for the vast majority of cases, just because it provides this user awareness of what's happening in the streams. But there's some devices where it's probably going to be difficult to get the support for it, or it might take more time. So then the CTA CMCB2 might help there. And so when we go look at the implementation, SBTA is all client side basically. So that's where you have the heaviest the burden is on the client to do it, while on the CTA is on the server to really build the tracking, while on the client is hopefully something that will support CMCD for the advantage of having CMCD tracking. Then we talk about certification, because sometimes you need to do certification for the advanced measurements in particular. So when you do certification, you have to do it per platforms. While if you're using the CMCD, you would be able to have your certification of your SGAI or SGAI providers, and that will be enough for it. Then you have the accuracy, which is of course much better in SBTA compared to CTA because it's coming directly from the client. But we are pretty confident that it is good with CTA. And then this difference of the calls coming from the client and the server, which have this advantage of avoiding ad blockers when it's done from the server, but also the disadvantage of ad servers not very too fan of having all the beacons, all the tracking URLs coming from a small set of IP, because of course it's easier to fake traffic that way. But that's also another thing, is that you have this confidentiality, because you're able to hide information from the client when you're not going through directly from the client to the ad server. And then again, this player awareness and viewability, which are really only possible with SVTA, because you need something on the device, on the client, to be able to really provide this enhancement and measurement. And so what's the viewability measurement? Is, like I was saying, the main thing is that it's the closest you can get to know if somebody's watching an ad. So it's watching basically what is the application doing. So it's looking at the display that is used to show the ad, how much of the screen is actually using. Is it really full screen or not full screen? Is anything on top of it? So it's like we have what we call like obstruction, which can be a friendly obstruction when it's like a companion ads, like a banner that is linked to the ad. So that's friendly, or like the play button. But then it can be also another web browser that the person is put on top of it. So that means that's, of course, he's not really watching. So this is the only way to know that. And you also know what's the actual vulnerable, and you still keep on trying on tracking the playback. So you're still finding the quartiles and the impression through that way, in addition to the other way. And then really, this is the closest way you know that somebody is watching the ad, because we're still not turning on the camera and looking at you. So still a little bit of privacy so far. And so how it works is really based on the IAB standards. So that's the new thing that's coming up. Previously was all company doing their own thing. So it would be using vPaid or their own SDK, but now the IAB provides you with this OM SDK, and you have this OMID API, which you integrate with your player. And basically, you just provide your video elements, and then you send your view playback events, viewport change, or volume change to this IP, and then it takes care of telling the OM SDK to fire all the measurement as required. And this implementation, you need to certify it with the IAB for every platform that you support. So it's iOS, Android, CTV, web. You will have to have a certification for all of them and renew it every year. And so in conclusion, rich and accurate measurement means you get advertiser confidence. So that means if they trust your measurement, they will trust that what you're saying is true. So they will be willing to buy more opportunity from you, and they will pay also better opportunity if you have more information, like accurate, but also the viewability. And then these new standards, which are being developed, allow to make it easier for you to integrate, also easier for you to select which provider you want to use. And just like SGAI and SGAI is not going to be switched to one of the standards across everything at once. It will be a slow migrations. But we believe that with both of these standards, you will be able to cover all of the use case you have. And that's it for me. Thank you.
Amazing. Thank you, Oliver. Do we have some questions from the audience? Zachary? Oh, was a question or applause?
I hit the wrong button. Sorry, but very nice.
Thank you. Great. So yeah, I imagine when we were talking, Oliver, like imagine like the old TVs and adding all these SDKs and stuff. Like the approach was, as you said, as conclusion, like, yeah, this is not something that just one tool will fix everything. Sounds like depending on connected TVs, depending on, it's not the same to have a, I don't know, a browser that understands viewport, or what happens if you have no browser support or whatever. Sounds like the future is a hybrid for everything, and that's complexity for sure. Tasso, do you have a question?
I do actually, yes, about the CMCD implementation, or at least, Olivier, what do you think, how this is going to be implemented? Because CMCD v2 introduces different modes to send CMCD signals, basically, right? So do you think this is going to go through request mode and data will be attached to segment requests, or is it more like an event mode implementation, or a hybrid?
Yeah, I think maybe an hybrid. It might depend, I guess, on the vendor also of how they implement the tracking. On our side, we want to have like a playhead tracking, like the playhead position sent to us every second or something, at least as frequent, and then just get the playback events. And to us, that's basically the way it works when we have our SDK on the device. It's just we get playhead position every 250 milliseconds. So I probably don't know if it's something CMCD would allow. I think we were fighting to get 1 second. But the idea is like to get a very short cadence on the playhead positioning, and then events as soon as they happen when a user press skip or mute or unmute. And also, I think Nicola added like the interstitial events, so we also be able to know when the interstitial events start and end, when there is discontinuity. And I think the main thing will be also to get this tracking, which is going to be done server side. As I was saying, like the file that it goes from a subset of IPs compared to the client side is something that we need to also work with advertiser on making them agree that this is an acceptable drawback for having tracking on more devices. Because right now, when we're doing server-side tracking, the tracking is not accurate at all, and so it's never something that we've been able to use at scale. It's always been like for a very small set of device, or when you're launching, then you agree with advertiser, you can do server tracking for a couple of weeks, but there is always this requirement that you need to go to client side. And especially when you're doing programmatic, like unless you're a big brand, it's really hard to get them to do server side. So I think there's some work that we need to do on our side with IAB and to see if that how to make an advertiser accept this drawback of the CMCD tracking, and maybe there is some MTLS certificate to put in place, or some way to whether we have also for server side calls to make sure that the ad ecosystem is happy with this.
Great. And I remember we have the discussion about the playhead to talk about, playhead should be this, and to avoid the issue you mentioned about live events, depending if you are using HLS or Dash.
So we set a long epoch time, like the BBC. So it was the British again decided.
Yeah, that's great, and that's already implemented also in the CMCD draft we implemented for Dash.is and Shaka. So you can already start doing some trials to track this.
You're too good, Nico. You're too good.
Great. Any other questions for Oliver? Amazing. So
I mean,
thank
can I ask stupid stuff? Because
there is no stupid questions, Tasso.
well, hear me out before you say that. So I'm very curious about your thoughts on that issue with the timeline, basically, right? So because my understanding is that, okay, I understand Apple Player implements it the way that they implement it, but I also think that the reason for this is that they come basically from Transport Stream, right? And Transport Stream with their 31-bit number for a timestamp is like, it just rolls over way too quickly to use that reliably. So they start at 0. Okay, fair enough. But with fragmented MP4, we can use reliable timestamps, right, in the media. So why? So does that need to be a problem actually, or can we just say, okay, whatever is your media timestamp is actually a timestamp? End of the discussion? Question mark. And now you can judge if this is a stupid question.
Well, you're the expert there, so
No, I'm not. That's why I'm asking.
I'm not the player expert. Yeah, I don't really know. Like where we are right now, that we're trying to figure out how every player does it, and we just that's really where we are right now. We see they all do it differently. And so when we were doing the CMCD, as Nico was saying, and we were having a lot of discussion on how to do it, because we are, what we were saying that, oh, we see Apple is doing this way, Shaka is doing this way, Dash.js is doing that way, but we wanted to have a single way to send to the server to make it easier for us. But not sure if the epoch time which we decide is the best. It sounds good to me, but I'm not the smartest person in the room, so
I think Tasso, again, I don't know if I'm right, but not always we have like access to stream level information in our players. Maybe you just give MSE whatever you receive, and you don't know what is inside of those boxes. And maybe you don't have even APIs to get the timing information of the packaging. So I think the solution we have right now, because it's calculated from times from the manifest, I think this is the best we can have right now. I'm not going very in deep because sometimes we cannot.
Yeah, I mean, I'm not saying anything against the solution. I totally like it, right? So if it would be all just okay, we agree on one time.
But also the manifest manipulator, like on our side, we don't have info from the segments. So all the timing info we have is from the manifest. So we need to have something that is from the manifest. So when we have an event start, it needs to be the one we need to be able to compute a start time purely using the manifest and not something that is inside the segments.
Which at least for the, so I do see the problem on HLS, right? Because you can basically do whatever you want. Your playlist starts just with an arbitrary segment, and there's no time information attached to that whatsoever. Like if you're lucky, you have XX program daytime, and you can, pin it to some relative position, but that's about it. In Dash, it is a little bit different, right? Because you have availability start time in the MPD, and that technically should be the 0 point in your media timeline.
Yep.
Even if that segment, never existed because your availability start time is Unix epoch 0 somewhere in the 70s, but that's your 0 point, right? And so now all your timestamps in your media segment are relative to that. And they're always relative to that. That's what availability start time is. So at least in Dash, if it's done correctly, that should be your timeline. It's I don't see the ambiguity. I see the implementation problem, right? So maybe it's like an interop problem where we just need more tests or more test cases around this, and maybe some guidelines on what all of this actually means. Which, by the way, just FYI, does exist. DashIF has a very, very good timeline document. It's a little bit outdated, but still captures the Dash timeline quite well. But I think this problem is not necessarily a spec problem, other than, again, maybe for HLS, where if you don't put XX date range, you just get arbitrary whatever is in your media segments.
Yep. So what I understand is by design, you don't need time information in the HLS. By designing Dash, you do. Right.
Yes. What it means, nobody knows. You can make this not related to actual
Nope.
physical time whatsoever. That's totally legit. You can absolutely do that. Should you do that? No, probably not. But
if someone can do it, that will happen. Great. We're approaching time, so I don't want to. I just want to keep on the time box we have. So again, thank you everyone for being here. Thank you, Zachary, for presentation, and Oliver. I think we have a big overview of everything you need to understand if you want to get paid for your ads and how to put them. So thank you again for being here. Thank you for all the audience and all the questions. And see you in the next one.